The use of transplants in vegetable production systems is important. They can provide a means for having early harvests, lower seed costs, enable farmers to gain a competitive advantage over weeds, and avoid costs associated with thinning. Transplants are integral to today's vegetable production in California and account for just about 100% of planted acreage for crops such as tomatoes, celery, and cauliflower. The transplant production industry is highly specialized and very innovative. This video provides an introduction to this important and dynamic segment of vegetable production systems in the state. We will showcase state-of-the-art transplant production in greenhouses and crop establishment equipment in the field.
My name is Sat Bath. I'm the greenhouse manager at Westside Transplant. We have 4 facilities. We majorly do vegetable transplants. Our biggest crop is processing tomatoes, but we do everything, basically peppers, cauliflower, all the brassicas, watermelons. Mainly anything from asparagus to zucchini. You have seed, we will grow transplants, and most of our stuff goes out to growers. And we do conventional transplants, and we also do organic transplants.
Sat explained that once they receive a transplant order, the first step is to place the order into their computer and determine the timing. He explained that timing is the key to ensure they allow enough time for the seeds to grow properly and the order delivered on time. Once the timeline is in place, they start with seeding.
So the first thing is our soil mix we use for most of our vegetable transplants are, it's a peat perlite mix. Usually maybe we might add some redwood and some, we also use a pH correctional in there and a wetting agent. So for vegetable transplants, you're trying to use components that are consistent, every time we get a load. So we try not to add a lot of fertilizer to our mix, so we like to add our own fertilizer. So once the soil is actually mixed, brought to us, we drop it into our trays, and then the trays, if you looked at them, they all get filled up, and then they get scraped off. The right compaction, that's very important on that machine.
Transplants are typically grown in trays with small cells in which individual seeds are placed. It is important to remember that the cell size on a tray is dependent on the seeding equipment and the transplant machinery.
The next thing is it's dropping the seed, and the consistency on the watermelons, the seed is a little bit bigger, so there's some misses or doubles. So we're trying to fill those in by hand, and then it goes through a vermiculite, which is the topper on the top. Most of the time the topper on the, we use vermiculite is because it's a neutral product and it holds good water without having that seed getting saturated. And then after that, we put the water on, and from there it goes into our germ room. And watermelons normally in our germ room will stay about 85 to 87 degrees. And most of our vegetable transplants will stay 2 to 3 days. And maybe like peppers or celery might stay 7 to 8 days. So what we're trying to do in our germ room is just sort of try to get them where the seed coat is actually, it's just germinating, but we don't want the plant to actually come up. And the reason why we do that is we have more of a consistent heat variation in our germ rooms instead of our greenhouses.
And then the hardest part is growing them out, and depending on crops, our fertilization practices, we also have to worry about any disease issues from fungicides, insecticides. So that goes into it. We have a lot of people that go into it. Most of our greenhouses all are computer controlled, so we can control the environments, the humidities, and also we are monitoring all aspects from growth, fertigation, and also to insecticides and everything else.
The next step is to move the transplants into their computer-controlled greenhouse.
These are some tomatoes that that just finished germing. They're about 10 to 12 days old. These plants will probably take another 45 days to finish. And if you look at these trays here, each tray has about 450 cells. And if you go across this whole bay, there is about 750,000 plants. At this stage, we're just making sure we're watering them, and then this will get fertilized probably next week. Next week, we'll start opening up these houses, trying to get them more natural light, and we'll start a fertigation program, and then we will go into a preventative fungicide and insecticide program, which we have developed over the years to do that.
Sat said they use automated sprinklers to irrigate the plants. With this system, they can uniformly water all of the transplants. Another unique feature to this greenhouse is their ability to open the roofs to give the plants direct sunlight. This also helps strengthen their plants by introducing them to some natural wind.
Hardening of a plant is to make sure when it goes out to the field, and depending on the environment, we want to make sure it can withstand the environmental conditions it's going into. So what we try to do for the last 2 to 3 weeks of its cycle, most of our greenhouses, we can open up roofs, keep them open and lower the temperature depending on if it's going into spring, it's cold, we try to harden them off that way. In the summer months, we try to harden them off by getting them used to the 105, 110 degree weather they're going into. So what we're trying to do is, when we say hardening, is getting them ready to the transplanting stage they're going to be going into. So the hardest thing is to make sure you give them a nice, well-rooted plant at the right height, disease-free, and that's our goal. And day to day, that's what we try to do. I think when most people think of greenhouse production, they think you have a total environmental control. We do not. Depending on Mother Nature, we might have fog, we don't have lighting. So those are some of the challenges of just growing the plant. One of the things that if we're doing this is we don't have enough experienced people. That takes time and patience and watching the plants. You have to observe the plants on a day-to-day basis.
Once the transplants have grown, they are delivered to the farmer in large wooden crates, unloaded, and then positioned onto specialized machines for field transplanting. A variety of transplanters are typically used, including rotating carousel types and finger-type machines that grab the transplant stem using rubber fingers. Plants are placed or positioned into the soil erect, and then large metal press wheels on the transplanter close the soil around the seedling to provide good contact between the plant and the soil. Generally, there are some people who will follow behind the transplanter to fill in missing plants by hand. Another advance in transplanter technology is the introduction of automatic transplanters that have come into use in recent years. This particular type of automatic transplanter works by the use of a mechanism that generates pressurized air to drive a ram that pushes the plants out of the bottom of the tray automatically. Considerably less labor is required using these automated innovations, but people are still required to walk behind the machine to fill in skips or missing plants. Great uniformity of spacing, growth development, and maturity can be achieved by these technologies. Following automatic transplanting into relatively dry soil, sprinkler irrigation is normally started right away to get the plants started and to make sure they're not stressed. A recent major advance in transplanter technology has been the commercial introduction of plant tape, a labor-saving machine innovation that relies upon the use of biodegradable transplant tape that is fed through the transplant machine and onto the soil.
So this is our product called the plant tape. Each plant is grown in an individual cell in a tray of 810 plants. So it has quite a few more plants in your normal conventional tray. Those are usually 338s or 210s. This one has 810. Now, the purpose of plant tape is really to save on labor. Conventionally transplanted crops usually have about 17 people out here per crew. You've got a tractor driver, about 8 people sitting on the planter, and then another 4 to 6 people following the planter and filling in blanks or making sure each plant is planted perfectly. With plant tape, the machine does all that for you. You need 3 people, 1 tractor driver and 2 crew members on top, moving trays through the machine.
The 2 crew members on the tractor string the tape through the troughs into the back of the module.
There's a knife block at the bottom of the module that's cutting each plant into whatever plant-to-plant spacing that you need. You can input any spacing that you want. So if you want 10.25 inches plant to plant, that's what you'll get. We run usually around 5 miles an hour, which is a lot faster than a conventional crew. And that's gonna give us about 2 acres per hour with 3 people compared to conventionally 17 people and 1 acre an hour. So each tray is connected to the next with a clip. So in theory, we never have to stop until we're out of plants. But it's important to realize that it's not one continuous string of plants when it gets into the ground. It's cut individually. Each plant is cut individually to get whatever spacing that you'd like. 3 problems for farmers: land, labor, water. It gets harder to farm every year. First of all, there's no people to farm. No one wants to break their backs out here. And it's more expensive every year. Minimum wage is going up, overtime's through the roof, it's ridiculous. Water's, a whole different story with the water board and all that, and then every year there's less land to farm. There's copper impregnated in the tape here, and that's so when the tape is zigzagged into the tray, the roots don't bind up through the tape. It looks like a zipper, right? So if there was no copper, the roots would be going crazy through the tape, and as you're trying to rip this apart, it'd be causing too much tension and breaking the tape.
So what does the copper do?
It stunts the roots. Not stunts, I guess, blocks the roots going through the tape, because we want it to go down through the bottom of the soil. Normally, conventional transplants are quite a bit bigger, right? So with plant tape, we have a smaller plug. We have a smaller plant too and a younger plant. So usually a conventionally transplanted broccoli, they're about 30 to 45 days. About 35 in the summer. With plant tape, we're at 23 days. So more plants in the greenhouse, less time. We plant faster with less people.
The new plant tape technology is now being introduced to vegetable farmers throughout the state at a variety of public field days. Because vegetable production in California typically relies on high-value inputs and has high costs associated with it, today's very widespread use of transplants is a good fit for successful, efficient production.